Geometry transformations. Reflection. Reflection is like working with a mirror. You have to first of all identify though where that mirror is going. So where is the axis of reflection? So let's start off just as saying that the axis of reflection is going to be the x-axis. What that means is that each point is going to be reflected in that axis, and we can figure out where those reflections are going by first of all drawing some construction lines perpendicular to the axis of reflection. We'll just go straight down through that axis of reflection. Then we look at each of the vertices, and we can see that this one went over 3 and up 2. Now this time, to get through the axis of reflection, we're going to go over 3 and down 2. So we can put that mark there. With this one, we went over 8 and up 7. This time we'll go over 8 and down 7. And for the third coordinate, we went over 9 and up 4, so this time we'll go over 9 and down 4. Then we can use each of those 3 points to join them together, and that gives us our image. Now, just to make it a little easier to see, we'll delete those 3 construction lines, and you can see now that it's reflected in the x-axis. So this point maps to that one, this one to here, and this one obviously goes to there. Now that was a reflection in the x-axis. We could also do a reflection in the y-axis. And we follow a similar process. This time we're drawing the lines horizontally. So that they're again perpendicular to the axis of reflection. And this time, rather than going over 3 and up 2, we're going to go to the left 3 and up 2. So that gives us a point there. For this one, instead of going over 9 and up 4, we're going to go to the left 9 and then up 4. And this one, instead of going to the right 8 and up 7, we're going to go to the left 8 and up 7. And then join those 3 points together. And you can see we've got the same shape. This line maps to there, that point maps to there, and that one goes to there. So far, we've been working with axes of reflections that are the origin axes, the x and y axes. We can, however, use other axes of reflection. For example, another common axis of reflection is the y equals negative x or x equals negative y line. We can use the same process of drawing construction lines perpendicular to the axis of reflection from each of the vertices. And in this case, what's effectively going to happen is that for each vertex, the x and the y coordinates are going to change. They're basically going to flip. Let's look at the first vertex. We went to the right 3 and up 2. Now for our new point, we're going to go to the left 2 and down 3. Let's see how that works. So what I'm saying we're going to get is instead of having 3, 2, we're going to have negative 2, negative 3. If we look at where that falls, negative 2, negative 3 is right there. Similarly, instead of having 8, 7, we're going to have negative 7, negative 8. And instead of 9, 4, we're going to have negative 4, negative 9. Negative 4, negative 9. And then we join those 3 points, and that gives us a reflected image that is reflected in the axis of reflection, which we identified as being y equals x or x equals y. You can see this coordinate went to there, this one goes to here, and this one goes to there. Now the final type of reflection we could do, we've done the x-axis, the y-axis, and y equals x as an axis, but we can also do some other arbitrary axis. So in this case, this is going to be our axis of reflection, and you might recognize that that axis of reflection is x equals negative 2. Following the same approach we've done previously, where we draw construction lines from each vertex, horizontally in this case, so they're going perpendicular to the axis of reflection. And then I just need to figure out the distance from the axis of reflection to each of the vertices. So in this case, we're going from positive 3 down to negative 2, which is a distance of 5. So that means I need to go 5 to the other side of the axis. 1, 2, 3, 4, 5. So at negative 7. Similarly, 8, 7, we are 10 from the axis of reflection. So that means we need to go down to negative 12. And here we are 9 plus 2 from the axis of reflection, which means we're 11 from the axis of reflection, which means that is going to be at negative 13. And then we can join up those three coordinates. And you can see that this is reflected there, this one is there, and the third one, of course, is there. In theory, you can reflect around any straight line. Obviously, we've done easier ones because they're either horizontal, vertical, or on the 45-degree diagonal. But in theory, you can do them on any equation, on any straight line.